We need to know population trends of species as well as the status of important habitats worldwide. With that information, we can prioritize which ones need special interventions.
We protect biodiversity by recording plant and animal access to cover, food and water. Gathering such information and sharing it in coordination with Geo Bon is vital to understanding and protecting nature's life in the reserve.
Introduced plant and pest animals are a major threat to New Zealand's native species, ecosystems and conservation lands. Control programs, which include government, NGO and communities, are essential for the survival of New Zealand's native species and ecosystems. The formulation and implementation of these control programs requires information about the ecology and distribution of both native and pest species. As well, we need data and information about how emerging threats, such as climate change, are likely to affect the behaviour and distribution of these species.
At the Latin American School of Protected Areas, we use the information of ecosystem and species distribution to design and improve conservation areas. Park managers need reliable databases to make informed decisions. The best way to have access to these updated databases is the collaboration of the different stakeholders. Geo Bon is helping to create this infrastructure.
As part of the early detection and rapid response program, it is critical to know which species are invasive in other parts of the world and how they spread and naturalize. Having a coordinated community of practice such as Geo Bon is invaluable to access to information and rapid decision making.
I think that information systems storing data on species are important for public policies related to planning and management, biodiversity and conservation.
Hello, I'm an environmentally concerned citizen and I'm passionate about birdwatching. I'm particularly interested to know what the blue swallow gets up to on its migrations into tropical Africa. I would like my own observations on blue swallows to be useful to the rest of the world.
People have observed and recorded biodiversity, probably longer than any other aspect of the environment, because it is important in their lives. Yet, at the beginning of the 21st century, when the richness of life on Earth is under serious threat worldwide, decision-makers lack the comprehensive, consistent and sustained information they need to stem the loss. There are good reasons why putting together a global picture of the status and changes in biodiversity is so hard. The first is that most biodiversity information is collected and stored locally or nationally. In order for this information to be shared, differences in methods, names, and data storage protocols have to be resolved. The second is the sheer complexity and diversity of information about life on Earth. There are over 1.5 million known species, and it is speculated that the true number may be 10 times higher. Each of these species consists of tens of billions of individual organisms, each of which has a unique genetic makeup. These genes make up the library of 4 billion years of evolution, codes that ensure the survival of that species and ours. The species combine in intricate ways to form thousands of ecosystems on the land, in rivers and lakes, and in the sea. These ecosystems provide us with the food, fiber, water, air, and medicines we need. Their interactions ensure a stable biosphere, protecting us from floods, diseases, and climate change. They are the fabric of the landscapes that we love. Bringing together the many forms and sources of biodiversity information is the ambition of the Group on Earth Observation Biodiversity Observation Network, Geo Bon. Here is an example of how it works. Satellites, continuously orbiting the Earth, take images of the Earth's surface. These images can be used to create maps of things like terrain, climate, and soil variables. They can also provide an indication of how land use changes over time and give an indication of the condition of the vegetation. This information can then be linked to a map of biodiversity patterns based on millions of records of plant and animal occurrences. The museums and herbaria of the world contain billions of specimens. The Global Biodiversity Information Facility, a partner in the network, has made many of them digitally accessible over the Internet. Combining these remote sensing and biodiversity data, Australian partners in the network are able to determine how much of the overall biodiversity has been retained over time. This allows indicators of loss and threat, such as those found in UNEP's Global Biodiversity Outlook 3, to be calculated. Another example. Observations in the field, many by amateur ornithologists, form the core of the vast data holdings coordinated by BirdLife International. Bringing them together over time and space allows trends in distribution and abundance to be calculated, forming the basis of the wild bird indicator in use in Europe and North America. It would be wonderful if this indicator could be extended to the tropics, where biodiversity is concentrated, and if other forms of biodiversity, such as plants, fish, and insects, were also covered. Geo Bon's 5-year objective is to facilitate the flow of information needed for the Convention on Biological Diversity's indicator set. But right now, some other early products are already available. The 60 years of continuous plankton recorder data from the North Atlantic clearly show how copepod assemblages of the open oceans, a critical fisheries resource, have shifted northward over time as a result of climate change. This tool, developed by the Joint Research Centre of the European Commission through a collaboration with the World Conservation Monitoring Centre, BirdLife International, the Royal Society for the Protection of Birds, and the Global Biodiversity Information Facility, allows the assessment of the state of African protected areas and the ability to prioritize them according to biodiversity values and threats in order to support decision-making and fund allocation processes. Biodiversity is part of humankind's collective inheritance, currently under unprecedented threat. Let's mobilize the power of global information to help save it, for our own good. The Global Biodiversity Observation Network.